Thank you, Annette. Good morning. So yeah, my name is Carl. I work for Fonterra. I am a senior laboratory project technician. The title just kind of keeps getting extended as I move up the food chain a little bit, but I basically look after the laboratory instrumentation for the Fonterra Regional Laboratory at Te Rapa in Hamilton. So yeah, when Annette asked me if I could talk about how measurements affect decision-making in producing food products, I thought, well, this will be easy. This is my job. This is what I do. So yeah, and I calibrate lab equipment that allows me to decide if that equipment is suitable to be used in testing. The guys test all the products, and that allows us to say whether or not we can sell it. Job done. But it's not really that simple, is it? Part of the complexity comes from the size of the company. So taking a few steps back, looking at Fonterra in general, we are a dairy cooperative, which means our suppliers are also our owners. They're our shareholders. So there are about 9,000 dairy farming families in New Zealand that are our suppliers. And globally, we have about 19,600 employees, which obviously jumps up and down all over the place as we hire more people and lose people. So for our process of actually making the food, we have a whole lot of dairy milk tankers, around 500 milk tankers in the milk collection part, picking up milk from our 9,000 dairy farming families. They travel over 90 million kilometers a year, collecting over 16 billion liters of milk a year. That was the numbers from last season, I believe. The season before that, I think it was about 17 billion. And globally, we have milk pools as well. And so I think globally it's around 22 billion liters of milk. I think there's another about 5 billion liters in Australia, and then the rest is elsewhere overseas. So these milk tankers travel around, and then they come bring all of that milk to 28 New Zealand manufacturing sites around the country. And these manufacturing sites produce around 2.7 million tons of product in total. So that 1.6 million tons of whole milk powder, that shows whole milk powder is one of the biggest drivers of the global milk price, because that's where a lot of that product goes to. But in terms of the amount of types of product, it's huge. There's milk powder, but there's also liquid milks, cultured milks, protein powders, caseins, and a whole lot of specialty products. There's cream products, butters, AMF, cheese products, a few specialty ones like lactoferrin, pharmaceutical lactose, and a little bit of ethanol still, although that's reducing. 95% of these products that are made from New Zealand milk are exported. So we actually only keep around 5% in our country and use ourselves. So if we didn't export that, we would have a lot to try and use ourselves. And we export to around 130 countries. So that gives you an idea of scale, which makes things a little bit more than just our little lab. Our lab is just one tiny corner of Fonterra, really. So Fonterra's, the way they look after our product is basically, their concept is grass to glass. So they look after all the steps from the farmers all the way through to having it in your glass on your table at home. And in terms of measurements, there are measurements in pretty much every single step along the way that enable the decisions. You know, and you can have decisions without measurements, but they'll be uninformed decisions. And your company probably won't last very long if you have no measurements at all. So looking right at the very basic part, right down to the grass before the cow even eats it, What do you think some of the measurements might be at that level? Yeah. So I'm not a farmer, so I don't know all of them. I can guarantee there's going to be a lot, but the ones that I can think of would be soil. They do a whole heap of soil testing, and quite likely water testing as well. So to grow the grass, they need to have a certain number of nutrients in it, and so they need to test the soil and make sure that they've got what they need or what they need to add. So then they can actually add the right amount as well. So there's a decision right there about adding the right amount, because you can't add too much, because then it gets flushed into the water systems, and then it affects the water systems and the environment as well. So right at the very base, you've already got measurements that are helping with decisions. Going into milk collection, when the tankers are picking up the milk, there is a whole heap of testing that the tankers do themselves. So there's actually little test kits that they run testing for antibiotics. We need to know if there's any antibiotics on the tanker before it actually gets to the plants, because if there is any antibiotics in that tanker, it affects an entire silo and we can't use it. So when they're actually picking the milk up, they're actually taking samples from each farm and they're testing for antibiotics on the truck. There's flow meters on the truck because they need to know how much milk is actually going on from each farm. They take samples from that, which go to Milk Test NZ. And Milk Test NZ then do a whole lot of testing as well. And they need to, one of the main things that especially the farmer wants to know is how many kilograms of milk solids are in that sample per volume. So with the volume from the flow meter, we know how many kilograms of milk solids have come from the farm, and they can actually get paid the right amount. Then we get into the actual processing. Processing is huge, and the amount of measurements in it, I can imagine, would just be astronomical. There's speeds around separation. You have to be able to separate the milk into skim milk and cream. There's temperature just all the way through. So we've got pasteurization temperatures, there's heat treatment steps, there's cooking steps, there's drying steps. The temperature goes up and down all over the place throughout the whole processing, depending on the product that's being made. There'll be weights and volumes, making sure that your ingredients that are going in, and basically what you're doing is cooking something. You're making food. So same as you're doing at home, you have a recipe. So we've got a whole lot of different recipes, even within making milk powders or protein powders. There's a whole lot of recipes that they have to follow to make a particular spec for a particular customer. And so they'll be having additives that have to be added in. And if you don't add the correct amount, then it's going to be out of spec. Packing. There is a whole lot of measurements in packing as well that affect decisions. All of our products are obviously packed to a certain trade standard that we just heard about. And so all the packing lines, we have to make sure that we've got scales to measure them that are all calibrated and checked and suitable to make sure that we're actually putting in the correct amount. Storage. There's the main one that I can think of in storage would be temperature. Again, there's always temperature all the way through this whole process, and probably in shipping as well. Shipping almost sort of falls under storage because with being stored in a ship instead of stored in a big shed. But the majority of our cultured milk products and cream products all have to be cooled and stored in cool storage, and that all has to be monitored. So throughout this entire process, there's measurements being taken that affect what we decide to do, how much we decide to stick into the product. And where we fit in the lab is just a tiny part of this, around about where that processing and packing part is. is sort of where the lab jumps into it. So in terms of the laboratory system, we have 4 main regional labs at Te Rapa, Waitoa, Whareroa and Clandeboy. But we also support a whole heap of process labs around all the manufacturing sites. So the departments across the labs, Te Rapa, Whareroa and Clandeboy have a microbiology lab. And Clandeboy and Te Rapa also do pathogen swab testing, environmental pathogen swab testing from the plants. Te Rapa for the North Island, Clandeboy for the South. So we do some PCR testing in there as well now. All 4 have chemistry labs. Waitoa specializes, they do some specialty chemistry stuff. So they've got all the big fancy machines, all the HPLCs and GCs and stuff that I've never really seen because it's at a different lab. But they do all things like the vitamins and minerals and things like that for the testing. The other 4 do general chemistry and functional. So making sure that chemically everything that is in the product is where it should be and the amount it should be, and functionally that it actually works properly, it dissolves correctly, it behaves the way it should, basically. And sensory, we have sensory departments at Waitoa, Whareroa and Clandeboy who physically test the samples, see what it tastes like, see what it feels like, the texture, the smell. There's a whole lot of sensory testing that goes on as well. So all of that testing is giving us measurements to see if we can sell it. Is it made to the correct spec? Can we sell it? We are, all 4 of those labs are IANZ accredited to ISO 17025. We just had our audit over the last 2 weeks. And not just those 4 labs, but also a lot of the satellite sites. So our audit literally took 2 weeks because we audited the Te Rapa lab, but they also went out to all 8 satellite sites that we look after, looking at all the NIR testing and some of the other little accredited bits that happen in the process labs. So it took a little while to do. Across those 4 main labs, we have more than 450 staff, and we complete over 4.5 million tests a year. At Te Rapa lab, we do around about 1.5 million tests. Most of that is microbiology. So about 1.1 million tests last season was what the microbiology department did. And there was about 360,000, I think, was the chemistry department. So micro obviously has the biggest portion of our staff at Te Rapa lab. But in terms of nationally, micro is still also the biggest chunk of that testing, probably about 3 million tests, I think. So that's how much testing we do. And that enables us, that gives us the measurements to be able to say whether or not we can sell the product. But then it comes down to traceable measurements as well. So we are accredited, so we're traceable, but how are we traceable? What do we do? And that's where my job comes in. So rather than having a whole lot of people come in and externally calibrate all of our things, who would all have to be IANZ accredited to calibrate all of our equipment, we employ a technician like myself and like Catherine used to be at Clandeboy. And we do our own internal calibrations as part of an accredited laboratory. So my role at Te Rapa Lab, I cover the calibration and maintenance of lab equipment at the Te Rapa Lab and at 7 different sites across the Waikato and Bay of Plenty regions. I have to maintain around 1,500 pieces of equipment, and I do around 2,600 calibrations a year. I tracked it for a couple of years, so that's how I know that number. But the number of types of calibrations is sort of where we are a little bit more broad compared to a calibration laboratory. So most calibration laboratories that are IANZ accredited usually specialize in one or two or three sort of types of calibrations, whereas we literally calibrate internally every piece of equipment that we use. There's only a couple of things that we still don't do ourselves because we only have one or two and it's not worth it. The biggest volume for us is thermometers, temperature calibrations, especially in terms of me supporting the manufacturing sites as well. There's temperature everywhere. So we do thermometers, we do load probes and autoclaves. We do digital displays on ovens, incubators, fridges. We do automatic temperature compensation probes on pH meters and DO meters and conductivity meters. So there's a huge amount of temperature. There's also a large amount of volume just in a lab. The lab is always about volume. There's all sorts of different types of glassware. There's piston operated pipettes, digital burettes, dispensers, auto titrators. And there's also certain types of equipment, like what we use to test bulk density, which has a volume component to it as well. We have a very large number of balancers, both in the labs throughout the process labs and in ours. I've got, I think there's about 40 odd balancers just in our lab, and then I've got another 40 odd that I look after throughout all of the process labs. There's a couple of masses that we use, although we don't actually calibrate a lot of those anymore. Part of temperature is spatial distribution. That's another large one for us. So we've got a lot of ovens, incubators, water baths. They're the main ones, but we also have furnaces, hot blocks, hot plates. They all need spatial distribution performed on them. Spectrophotometers. I've improved how we do the calibration on spectrophotometers after doing the course that Annette ran a few years ago for me. And so that's a lot better now than it used to be. We do a little bit of drop height on the bulk density machines, a lot of time. We've got timers everywhere. Time is always sort of critical in a lot of the tests that we do. Speed for centrifuges and mixers. Comparison charts. We check all of our comparison charts for that we use for foreign matter, color of products. There's a whole lot of comparison charts that are used in functional and foreign matter testing. Load validation is another one that I introduced for us that we do ourselves now for autoclaves for the microbiology departments. So we do our own load validations for that. Recently, I've also introduced testing UV intensity and lux. Lux came out of a customer audit. There was certain standards that they required us to meet for areas within the lab that have a visual component to the test. There's a minimum amount of lux that the bench lighting has to be. So we had to quickly write some methods and work out how to do that. And ultra pure water conductivity meters is something that we've sort of changed how we do, and gets brought up in every time we have a new auditor. So we only actually calibrate ours every 3 months. We've ended up we've been able to validate that rather than daily, but it's due to the type of meter that we use, because what we're doing is we're testing the conductivity of ultra pure water for lab use. And when your upper limit for microbiology is 2 microsiemen and your upper limit for type 1 water in chemistry is 0.056, I believe. When you have a meter that can read a large range and you're calibrating it with a 23 microsiemen solution, you're calibrating it at a level that isn't even close to what you need. And more often than not, the accuracy of the meters that have the larger range is usually plus or minus 1 or 2% of the upper limit of the range. So you end up with the accuracy of the meter is more than what your actual test requirements are. So we sourced some actual ultra pure water meters that have a range of 0 to 2 microsiemens. So they read a very small range at about 3 decimal places. And we had to find a very low standard that we could use to calibrate those. But because of the standard is so low, they're also very expensive. And you don't want to be using that every day. So we validated that so that we could calibrate those every 3 months, which made quite a bit of difference, but it also means that we're actually sure of the conductivity of our ultra pure water that we use in our lab. So the range of calibrations that we do is rather large, and it feels like it keeps increasing all the time, but that's okay because it means I keep learning all the time. But ultimately what this sort of shows is this gives us the traceable part of our traceable measurements. So our labs are definitely producing traceable measurements, and that helps the company in terms of being able to make the decisions of whether or not our products are fit for purpose. They actually meet spec, they are safe for people to consume, and we can actually sell them to the customers. And that is what I do. The extended version.